Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome back to another episode where we unravel the layers of enterprise Java frameworks. Today, we're diving into Apache Shale, a framework that extends JavaServer Faces with powerful MVC capabilities. While not as widely used today, it remains a key tool for developers maintaining or upgrading JSF-based systems. Apache Shale is a framework that extends JSF to introduce model view controller architecture. It adds features like dialog management, view handlers, and lifecycle listeners that make JSF more suitable for complex enterprise applications. This makes it ideal for legacy systems needing modernization without rewriting from scratch. Shale brings structure to JSF applications by introducing MVC patterns and dialog flows. This helps in managing complex user interactions and organizing large-scale JSF projects. It's especially useful when you're dealing with legacy systems that require incremental upgrades. Shale's architecture is built around several core components. The application controller handles incoming requests, the view handler manages UI rendering, and the dialog manager orchestrates complex user flows. Lifecycle listeners provide hooks into JSF phases, and managed beans serve as the data layer. Shale's architecture extends JSF by introducing MVC concepts and a dialog-based navigation model. This allows developers to manage complex workflows using a structured approach. The framework also supports lifecycle interceptors, enabling fine-grained control over request processing. When a request hits a Shale application, it starts with a Faces servlet, which forwards control to the application controller. The dialog manager then evaluates the current dialog state, while lifecycle listeners respond to JSF phase events. Finally, the view handler renders the appropriate response. One of Shale's standout features is its dialog management system. Dialogs represent distinct user workflows and can be nested or chained together. The dialog manager maintains state across these dialogs, ensuring a smooth and consistent user experience. Shale relies on XML configuration files like shaleconfig.xml for defining dialogs and application behavior. It integrates with JSF's Faces config.xml for component definitions. This XML-driven approach provides flexibility but can become verbose in large projects. Compared to plain JSF, Shale introduces a structured MVC layer that enhances navigation and dialog control. It's particularly beneficial when dealing with complex workflows that require multiple steps or conditional branching. While both Shale and Struts are legacy frameworks, they differ fundamentally. Shale is built on JSF and uses a component lifecycle, while Struts is action-based. Shale's dialog-based navigation contrasts with Struts' action chaining approach. Shale is used in enterprise portals that rely on JSF for backend integration. A common use case is financial applications with multi-step workflows, where dialog management ensures consistency. It's also valuable in legacy app migrations where JSF is the target platform. While Apache Shale is no longer actively developed, it still finds use in legacy systems. However, it lacks support for modern paradigms like microservices and reactive programming. If you're building new systems, consider alternatives like Spring Boot or Jakarta EE. Shale brings several benefits to JSF development, including enhanced modularity and dialog-based navigation. It integrates well with legacy systems and provides hooks into the JSF lifecycle for fine-grained control. Despite its strengths, Shale has drawbacks. It's no longer actively maintained, relies heavily on XML configuration, and isn't suited for cloud-native or reactive architectures. Documentation is also sparse, making troubleshooting more challenging. Let's take a closer look at Shale's configuration. The Shale config.xml file defines dialogues and application behavior, while Faces config.xml handles JSF components. Lifecycle listeners are mapped in XML, and managed beans can be defined via annotations or XML. Here's how dialog flows work in Shale. Dialogues are defined in Shale config.xml, and the dialog manager tracks the current state. Transitions between dialogues are defined via outcome mappings, and the system supports both nested and chain dialogues. Shale's view handlers manage how views are rendered. They support various JSF view technologies and can integrate with templating engines. They also handle navigation outcomes, ensuring the correct view is displayed based on user actions. Lifecycle listeners in Shale intercept JSF lifecycle phases and allow developers to inject custom logic. They're commonly used for validation, data binding, and modifying the request processing flow based on business rules. While Shale traditionally used managed beans, integrating with CDI provides better dependency injection and contextual lifecycle management. This makes testing and mocking easier and aligns with modern Java EE practices. In terms of performance, Shale is on par with JSF for request handling. Dialog overhead is minimal for simple flows, but XML parsing can add slight latency. Memory usage scales with dialog complexity, so optimization is key in large applications. Security in Shale largely inherits from JSF, but developers must ensure dialog state is protected. Input validation is handled via JSF validators, and session management is typically handled by the application server. Migrating to or from Shale requires a strategic approach. Start with small dialog modules, migrate managed beans to CDI, refactor XML configs gradually, and consider a hybrid JSF/Shale approach for smoother transitions. Unfortunately, Shale has no active development and limited community support. Documentation is outdated, but it's still used in enterprise systems where migration isn't feasible. Consider this when evaluating Shale for new projects. If you're starting fresh, consider alternatives like Spring Boot with ThymeLeaf, Jakarta EE with MVC, or front-end frameworks like React or Angular. Vaadin is also a great option for component-based UIs. To learn Shale effectively, start with JSF fundamentals, practice dialog configuration, and use IDE plugins for XML editing. Exploring legacy codebases can also provide real-world examples of Shale in action. When working with Shale, keep dialog logic simple, use CDI for dependency injection, validate inputs early, and document XML configurations thoroughly. These practices will help maintain clarity and reduce errors. Shale integrates well with CI/CD pipelines using tools like Maven. XML configurations can be version controlled, but testing requires JSF-aware tools. Deployment is similar to standard JSF applications, making integration straightforward. Testing Shale involves unit testing managed beans and dialogs, using JSF unit for integration tests, mocking external dependencies, and validating dialog transitions. This ensures reliability in complex workflows. Shale can be deployed using traditional WAR files, embedded servers like Jetty, or cloud platforms that support JSF. Docker containers are also an option for deploying legacy Shale applications in modern environments. Shale is not well suited for microservices due to its monolithic architecture. It's better suited for legacy systems where migration to modern stacks may be costly or infeasible. Shale lacks native support for reactive programming and handles requests synchronously. It's not compatible with reactive stacks and lacks the async capabilities needed for modern reactive applications. Shale has limited cloud-native features and lacks container orchestration support. It's not optimized for scalability and struggles in modern cloud environments where agility and scaling are key. Despite its limitations, Shale is still used in legacy enterprise applications. Migration paths exist and integration with modern tools is possible, though documentation challenges can slow progress. There is no active development roadmap for Shale. Only community-driven patches are available, and migration to modern frameworks is strongly advised. Legacy support may phase out over time. The developer experience with Shale varies. IDE support is limited, configuration is XML-heavy, and debugging can be challenging. Legacy tooling also imposes limitations on productivity. In summary, Apache Shale extended JSF with MVC support and introduced a dialog-based navigation model. While it's a legacy framework with limited updates, it's still used in enterprise systems where migration isn't feasible. Thanks for watching this deep dive into Apache Shale. If this helped you understand its role in enterprise Java web development, hit like, comment with your questions, and subscribe for more technical breakdowns. See you in the next one. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.